Today we will solve the examples on hydroelectric power plant. Okay, and same examples with the change in values will be given as an assignment. Okay. So pay attention. Okay, the first problem is, okay, am I audible? Ajay?
Yes, sir.
Okay. A hydroelectric generating station is supplied from a reservoir of capacity 5 into 10 raised to 6. Okay, read it as 10 raised to 6 cubic meters at a head of 200 meters. Okay, the reservoir's height is 200 meter. Find the total energy available in kWh, means what? Output electrical energy. If the overall efficiency is 75%, overall efficiency is 75%. Okay, so the data is given as, okay, reservoir capacity. Okay, we use this symbol, I think Q is equal to 5 into 10 raised to 6 meter cube or cubic meters. Then head, that is height, is equal to 200 meters. Find the total energy available, okay, output energy E. If the overall efficiency is 75%, means what? Eta overall is equal to 0.75. Okay, this data they have provided. Okay, we know what is the overall efficiency. Okay, for example, if we consider the hydroelectric power plant, the stages are the dam is erected there. Okay, and the reservoir is formed. Okay, the energy stored in reservoir, okay, it will be a potential energy. It is a potential energy, and its formula is mg into h, mgh, where m is mass of total reservoir quantity, g is acceleration due to gravity, h is height of the reservoir, okay, that is head. Okay, next is penstock are there, penstocks are there, and the water will flow through the penstock due to gravity effect. Okay, so these, if we calculate the power or energy due to this running water, it may be called as a kinetic energy. It is in the form of kinetic energy, which is equal to half mv square. Okay, mass flowing through the, m is mass flowing through the this penstock, and v is velocity of that water. And after that, okay, it is given to what? A turbine section, powerhouse. Okay, it is given to water turbine. Water turbine converts this kinetic energy to mechanical energy. Okay, so the efficiency corresponding to turbine we can call as a eta turbine. Okay, and it can be calculated as, okay, eta turbine may be output energy, that is mechanical energy divided by input. Okay, input, maybe if we consider all these as most of the time these as one stage, okay, then in this case eta is equal to mechanical energy, okay, of turbine divided by potential energy. Okay, and the kinetic energy is a one stage of this part. Again, this turbine is connected to generator section. Okay, and this generator will have efficiency, the generator will have efficiency eta g The generator generates electrical energy. So eta G is equal to this electrical energy divided by input energy, that is mechanical energy. Okay. So if you want to use the efficiency, overall efficiency, okay, overall efficiency means what? All these things are considered as a one stage. Okay, where input is the potential energy stored in the reservoir, okay, and the output is the electrical energy. Okay, so in this case, if you consider the overall efficiency instead of just turbine efficiency or uh, generator efficiency, then eta overall, okay, will be equal to output electrical energy in kilowatt hour divided by input, which is a potential energy. Okay, it is a potential energy. So we can use this formula of overall efficiency to calculate output electrical energy generated in kWh. Okay, they have asked for kWh. So now we will solve this problem. Okay, to use this formula, we have to know which thing. First, we have to calculate the potential energy. Okay, we have to calculate this potential energy. The potential energy okay, is equal to mass of reservoir or mass of stored water into H means head or height into acceleration due to gravity, that is G, okay, which is equal to 9.81 meter per second square. Okay, we have to use this formula. Okay, for that, first we have to calculate the mass of stored water. Okay, they have not given the mass of stored water. Since mass of stored water is equal to volume of water, okay, they have given the volume of water, that is Q, in meter cube, in cubic meter or meter cube, into density of water. Density of water. Okay, density of water means what? If we take 1 meter cube of water, then how or what is its weight? Okay, 1 meter cube of water is equal to 1 kilogram. It will weigh 1 kilowatt. Okay, I will write here, since mass of 1 meter cube of water is 1000 kilogram. Therefore, mass of stored water, I will use the symbol small m, okay, will be equal to volume of water, that is Q, into density of water. We have given, we have known it is 1000, Q into 1000, but Q's value is given as 5 into 10 raised to 6. They have given this data, 5 into 10 raised to 6 into 1000 means what? 10 raised to 3, okay, which is equal to 5 into 10 raised to 9. Now we have mass, okay, we have head, we know what is gravity or acceleration due to gravity G, okay, we can calculate potential energy. Therefore, potential energy is equal to mgh is equal to m is 5 into 10 raised to 9 into g is 9.81 into h is head is 200 meter. Okay, 200 meter. Okay, it will give, please multiply 5 by 9.81, or I will do calculation here. 5 to 9.81, it is equal to 49.05 into 200 into 10 raised to 9. I have to multiply it again by 2 is equal to 98.1. It is equal to 98.1 into 10 raised to 9 into 200 means 2 into 10 raised to 2. It is equal to 10 raised to 11. Okay, now we have potential energy 98.1 into 10 raised to 11. Obviously its unit is watt second or joule. Watt second or joule, unit of unit of energy. Okay, we know that energy is equal to power by time. What is the unit? Sorry, power into time. Sorry, power into time. What is the unit of power? Is watt, and unit of time is second. So unit of energy is watt second, or it may be expressed in joules. So now we have potential energy, that is input energy. We can use the formula of overall efficiency to calculate the output energy, that is electrical energy output. Eta overall, since eta overall is equal to output electrical energy in kWh divided by, sorry, it is not in kWh. Why, I will tell you. Because whatever the unit of the denominator, okay, same unit of numerator must be there. Okay, the unit of denominator, that is input potential energy, we have expressed it in terms of watt second. Okay, so input in potential energy okay, if we have taken it as watt in watt second, then electrical energy output must be in, we can calculate it in watt second. Okay, therefore electrical energy is equal to the potential energy, which is equal to 98.1 into 10 raised to 11, 98.1 into 10 raised to 11 into overall efficiency, they are given 0.75 or 75%. Okay, it will give, 1 minute, I will multiplied it by, it is 73.575 into 10 raised to 11. Obviously its unit is watt second. Watt second. And if we want to convert it into watt hour, then we have to divide it by number of seconds in an hour. Okay, it is equal to 73.575 into 10 raised to 11 divided by 3600. Okay, it will give answer in watt hour. Okay, and if you want it in terms of kWh, then again we have to divide it by 1000. One minute, I will silence my mobile. Okay, it is equal to 73.575 into 10 raised to 11 divided by 3600 into 1000. Okay, it will give answer in kWh. Okay, do you get it? कसं कन्वर्ट केलं ते कळलं सगळ्यांना? जर काय डाऊट असेल तर विचारा, काय कळलं नसेल तर. आकाश रुपनर, हॅलो आकाश रुपनर. अजित अजित हा प्रॉब्लेम कळाला का कसं सोडवलं ते? ठीक आहे. ओके, कोण आहे, कोण होतं हे बोललं ते आता? हॅलो, कोण बोलला आता? अजित होता का आकाश होता?
अजित.
अजित आहे काय? आकाश का नाही वाटतं, नुसतं प्रेझेंट लावा गेला. Hello Ajay, am I audible?
Yes, sir.
Okay. Okay, now we will proceed for second problem. Okay. This is the second problem. It has been estimated that a minimum runoff. Runoff means what? Continuous availability of water. Okay, for generation purpose. Minimum runoff. Minimum. Okay, they have used the word minimum. Okay, that's what if you consider a dam. Okay, obviously in rainy season its head is maximum. Okay, and in summer its water content will be lowest. Okay, this what is runoff available, okay, during such a condition. Okay, it is nothing but what? Minimum runoff. Okay, in that case also the dam is must able to generate electricity. Okay, means what? A minimum runoff must be maintained. It has been estimated that a minimum runoff of approximately 94 meter cube per second. Okay, means what? 94 meter cube of water, okay, is flowing per second will be available at hydroelectric project with a head of, okay, they have given head of 39 meter. Determine the firm capacity. Okay, firm capacity is nothing but output electricity generated with minimum runoff. Okay, it is a firm capacity. Second, yearly gross output. Yearly gross output. Okay, what quantity of energy generated considering whole year, assuming the efficiency of the plant means what overall efficiency is 80%. Okay. Okay, we will solve now. Minimum runoff is equal to 94 meter cube per second. 94 meter cube per second. Since we know that 1 meter cube of water, okay, equal to 1000 kilogram. Okay, so therefore minimum runoff is nothing but what water available in any condition. Okay, so we can convert that minimum runoff in weight of water or mass of water. Okay, mass of water available during such a condition is equal to 94 into 1000. 1000 is equal to 94,000, okay, kilogram. Okay, this much of water is available per second. Per second, because 94 is meter cube per second. So 94,000 kilogram of water is available in a given second. Again, they have provided data of head or height is equal to 39 meter. Okay, so the work done or potential energy can be calculated as, okay, I will write down as input energy as a potential energy. Therefore, potential energy available, okay, is equal to why we cannot use the word potential energy in this case, because they have given data about runoff. Okay, means what running water. Okay, and running water does not possess a potential energy. Okay, but we can use in general the word hydraulic energy. Okay, obviously hydraulic energy can be used for uh, running water, means what kinetic energy. Okay, and that water is used to run the turbine. Okay, means what that running water is doing some work. Okay, so instead of potential energy we will use the word work done. The work done per second or work done in a second. Okay, or I will write potential energy available in a second, okay, is equal to work done per second. Okay, डू गेट इट. हे असं या ठिकाणी वर्कडन का वर्ड वापरला ते आपण, तर त्यांनी असं कॉन्स्टंट वॉटरचं काय असं इन्फॉर्मेशन नाही आहे, मात्र एका सेकंदामध्ये किती वॉटर फ्लो होतोय तो आहे 94,000 किलोग्रॅम पर सेकंद आहे, आणि इट इज ड्यू टू वॉट हेड ऑफ 39 मीटर. सो वी हॅव टू use the hydraulic energy instead of potential energy. Okay, it is nothing but what used to work. Okay, means what work done per second. Obviously we can use the same formula of potential energy. Therefore work done per second is equal to what is the mass of that water into head, okay, is equal into acceleration due to gravity. Okay, g mass is 94,000 per second into height, that is head is 39 meter into acceleration due to gravity is 9.81. Okay, which is equal to 9 0.81 into 39 into 94, it is equal to 35,963. 35963.46 46 into 10 raised to 3. Okay, due to this point 10 raised to 3, it will be in watts. Okay. Why it is in watts? Because we have calculated work done per second, means what? W per time. Okay, W is corresponding to energy, okay, per time, okay, which is equal to power. Okay, so it has unit of watts, so it is nothing but what? Input power. So we have input power in watts, okay, and we can convert it into kilowatt. Okay? 35,963.46 kilowatt. Now we have input power. We have to calculate a firm capacity and then gross plant, yearly gross output. Okay, I will just write it as input power. Okay. Input power means what? Hydraulic power. Okay, means what? We can use, or in book they have used the word capacity, plant capacity, input plant capacity, or gross plant capacity. Okay, this is the plant capacity of plant at any instant of time in a year. Okay, so first is firm capacity. They have asked for what? Firm capacity. And firm capacity is nothing but what? Output energy. Okay, output energy. Okay, so formula we have to use the plant efficiency or overall efficiency, eta plant. Okay, in this problem they have used a plant efficiency instead of overall efficiency. So I will write eta plant is equal to output energy, okay, when there is a minimum runoff, divided by, sorry, so here we have calculated input power, so instead of energy we have to use the word power. Okay, because the numerator and denominator must be the same. Instead of energy we have to use word power. So output power divided by input power. And output power is nothing but what? A firm capacity divided by input power is nothing but what? Gross plant capacity therefore firm capacity is equal to eta plant into gross plant capacity. Eta plant they have given equal to 80%, that is 0.8, into gross plant capacity we have calculated equal to 35,963.46. Okay, and the firm capacity will come in terms of kilowatt. Okay, because gross plant capacity we have calculated in terms of kilowatt. Okay, this will be the firm capacity into 0.8 is equal to 28770.768. 28770.768 kilowatt. Now the second point they asks yearly gross output. Yearly gross output means what? If the firm capacity is 28,770 kilowatt, okay, firm capacity is nothing but we just use the word output power, okay, not needed the word firm capacity, output power. If the electrical output power is of this much, okay, then what is the yearly gross output? That is, what is the yearly energy, annual energy? Yearly gross output is equal to annual energy, okay, which is equal to obviously output power into number of hours in year. Okay, power into time is nothing but what? Energy. Output power, that is firm capacity, is equal to 28.770, sorry, 28,770.768 into number of hours in year are equal to 8760 into 8760, which is equal to 25 crore. Okay, 25 2031 comma 927.68, 927.68. Okay, this much of power, okay, in this much of energy in kWh will be generated. Okay, we can convert into some simple units. Okay, 252.032 into 10 raised to 6 kWh. Okay, I just converted into this simple numbers. Okay, this is the yearly gross output, that is annual energy. Okay, any one of you have doubt असेल तर विचारा. Ajay, please take a snapshot of presenting.
Yes, sir.
31 students are present. Ashwini. Hello Ashwini. Ankare.
Yes, sir.
Okay, काय प्रॉब्लेम सॉल्व केलं कळालं का?
हो सर.
कळलं नसेल तर विचारा. नुसताच मोबाईल ठेवून बसू नका. काय कळलं नसेल तर विचारा. लक्ष द्या व्यवस्थित सर्वांनी. Okay, we will end lecture here.